Just completed BSc in Computer Science with Open University. Completed in December 2017 and I passed. I completed my BSc in Computer Science by completing the Computing and IT project. TM470, for those with the OU will know what that means. I decided to design a piece of software to virtualize satellites, not only around this planet but all planets in the known solar system. The theory behind it was, if we're gonna put bases on the moon and travel to Mars, we might need communication satellites around both of those planets. We currently have a lack of space around the geostationary orbit of Earth. Anyone who don't know what that is, a satellite travels 32,000 kilometers above the Earth around the equator. That's geostationary orbit. It travels at 17,000 miles per hour apparently, which is the same speed as the Earth rotates. So I created this piece of software in Java 3D. It's called S.O.M.A.V. It stands for Satellite Orbit Monitoring and Virtualization. Basically, I passed with this piece of software, but the tutor never actually got to see the software in action or working, or what it even does. I'm surprised they even passed based on that. I'm pretty poor at report writing, but I passed based on the report of this piece of software I'm not going to show. I've exported from Java IDE into a runnable jar. Nah, somehow I got errors with that and it can't find the resource folder. Normally the resource folder would be inside the runnable jar, and on this occasion it's not. So in addition to that, the application needs settings on the Java virtual machine to be set to use at least 1 gigabyte, or yeah, I think it's at least 1 gigabyte of memory, to be able to render all the 3D objects in the Java 3D universe that I've created, to which there are many planets, orbits, satellites, stars, asteroids, and each one of these is a 3D object, 3D model. So we're trying to render all of these to the screen at the same time. It's got issues, the software is not complete. I would call it experimental software. So anyway, I created a bat file. I just opened Notepad and create a simple run this Java runnable jar file with 1 gigabyte of memory. So that's where the bat file comes from, and the resource folder holds all the 3D models that the program uses when it's rendering. So basically you need these 3 files. You need the bat file, you need the jar file, and you need the res folder. As long as they're all in the same place, if you double click the bat file, then the runnable jar will run and we'll be able to find its resources. If for any reason the resource folder is not there, the res folder, it won't run, it'll probably crash out. The same goes if you double click the jar file, it will run without the gigabyte setting of memory, and in addition it may not be able to find the res folder. So it's likely to crash out if you don't have those 3 files and it's not run using the bat file that I've created. You can open the bat file up in Notepad and see what it looks like. It's just a simple command line, run this program with 1 gigabyte of memory, and it seems to work pretty well. I got a lot of the models to work in Java 3D. It took a long time to get them to the stage they're at the moment, and they're by no way, complete or finished. Java 3D is a really strange kind of hierarchical type of structure in the programs that you use, creating this environment, especially using virtual universes and simple universes. Basically a block of 3D space that you can place any model inside of. You can also use keys or mouse controls to navigate around the universe that you create. So once all the models are in, you've positioned your camera angles and stuff, or you've sorted out your key movement, or that, you can basically explore for hours and hours. Java 3D has a universe at the top, and it's a upside down tree structure below that, with two main branches. You've got the viewing branch, and you've got the object branch. I forgot what they call it. The scene graph with all the objects in it, with all the different branches, the different shapes, all the geometry. The viewing platform is what the viewer sees, or the point of view of the universe that's attached, or that view is attached to, can see. It's pretty complex in the view element. You need a view platform, and then you need a view. You need to create the universe with a 3D canvas and attach that to the 3D universe. It's pretty high level stuff. But then below that, those two branches, you have all the branches for each object. Each object starts with a branch group, and then you've got a transform group, and then you've got a transform 3D, which is I would consider it something that gives the transform group its values of where to move to, or where it should be placed within the universe. But then you can add behaviors to that transform group as well, such as rotate internally or rotate externally, given different settings. There's also pick and zoom, where you can click on an object and zoom in using your mouse wheel and things like that. It's pretty high level stuff as far as code goes and what you can do with it. I don't know if I like the virtual universe itself that Java 3D provides, or I'd like to create one myself and put these objects in it, but it works pretty well. It does have its limitations though. Java 3D will render from a viewpoint everything that's in front of that viewpoint, and it will do this so many times a second update. What it won't do is include in that update is everything behind the camera. What this means is if you turn the camera around too quickly, it's not got time to render everything at that point of view. So it slows down in its rendering, or you'll press the key a little bit to rotate to the left, and it'll go around halfway around, to the other angle, because it takes that period of time, skips over that period of time, like Back to the Future, to render everything that's in that point of view, which is a real drag. But that's also one of the reasons I gave it a gigabyte of memory, to try and resolve that. Plus it needed that with all the 3D objects it's actually rendering. When you first start the S.O.M.A.V application, it's probably best to go to the show and hide menu, orbits, and turn off all the orbits. The orbits were something that was supposed to be see-through objects that the satellites would travel around. And I never actually completed the transparency on those objects. I'm pretty much sure I can do it, but I never actually completed that bit. They also have a lot of vertices to draw out in the computer's memory, and there are lots of them. I've put every orbit I could get a list of around every single planet. So each one of these orbits made up of, 100 verts. And you've got 9 of them around each of the 9 planets. Yeah, there's quite a few verts. So turn them off, show and hide, orbits, show all orbits, turn that off. The next thing I would do is go to the animation menu, orbit, planets, I think, or orbit Earth, and turn Earth's orbit off. Again, without using the keys to move around. Keep looking at the sun when you first start. If you turn off all the orbits, stop planet Earth from orbiting, you can see it spinning in front of the camera, just in front of the sun. And that's a good place to start from. The next thing I would do to make sure Java 3D and the program itself knows everything that's in the scene is then press the right or the left arrow keys to turn all the way around, just so that all the objects are loaded at some point into Java 3D's memory. They won't stay. As soon as you move again, they'll forget that they're, like I said, only renders what's in front of the camera. But if you do that, it kind of speeds things up slightly. If you ever do get stuck with the view, which is very easy to do, go to the view menu, reset the view, and you should be looking at the sun again. I wouldn't use the buttons that are layered on top of the 3D universe, because I didn't actually fully program them in yet. Might never do. Don't know what I'm doing with this application, I just thought I'd show it anyway. Same with the GUIs on the right of the application. They were all supposed to be wired into the 3D objects in the universe, and I was still in the process of wiring those all in, so I don't know how much of that will actually work as far as seeing anything in the 3D universe changing. But if you select a different satellite, then the information for each of those satellites will change in the GUI part. Same with the planets, same with the orbits. The idea was you select a planet and the view would go to that planet. Never got to that part, but that was the idea. I added stars and asteroids to give the universe a more realistic kind of look, and it makes it quite immersive. I can sit and watch these asteroids rotate internally and around the sun for hours, and the program will do that as well. As soon as you run the program and turn off all the orbits and stuff, so your memory is not being lagging, then you can maneuver to the asteroid field and watch them just fly by the camera. It's quite amazing stuff. To say it's all pre-programmed, automatic, with exception to the spin. I think I put a bit of random on the internal spin. So each of the asteroids would, not only do they go around the sun at a different speed in comparison to each other, but they spin in different directions as well internally, which is a really good effect I managed to create. When I started this project, I knew absolutely nothing of Java 3D. I'd never used a library before. I had no idea about branch groups, transform groups, rotation, interpolators, none of that, But I knew how to create basic 3D models in Blender and Max, so this was something I actually wanted to do. You have a choice of what project you want to create at the start of the course, and it's got to be agreed with your tutor. I put a few ideas up, some cryptographic application, and a few others, but the one that stuck was the satellite monitoring virtualization. So that's why I created this. I'm not very good at writing reports. I'm terrible at keeping a schedule. Not keeping to a schedule, I'm just terrible at writing one out. So my scores reflect that as far as this final year. But I weren't expecting to get a 2-1 anyway, so yeah, no complaints. Well, one, I wish that my tutor could have seen the application. And I think that's why I'm doing this now, to make up. I'm going to put it out there anyway, just in case anybody else is interested in this or what. Future project I plan to do is create a 3D game using Java 3D, but that's still a very early idea at the moment. I've not got very far apart from creating the universe, so that I've put no objects in in the scene. When I was creating the branch group with all the objects in, I actually created a sandbox version of this with 2 universes. The idea was to have a second view of the same universe that you could look at, as well as, you know, the main point of view. You could look to the side or, you know, to the back at the same time. And I might be able to put that in a runnable jar as well and add that, but that's where I would create the 3D objects from the branch group and the transform groups, and then add the behaviors. The behavior, I couldn't get the behaviors to change on each model when you made a selection. So what I ended up doing was making 4 of the same planet. So we've got one of the planets that's spinning and orbiting. One of the planets is completely still. It's not moving from its absolute position. A third one is spinning, but it's static. And the 4th one is orbiting, but it's not spinning. Right, I know that's confusing. The reason I had to do that was because I could only apply one set of behavior to each model, and I couldn't change that while the models are live. So basically what happens is, if you click on the animation menu and you tell it to stop orbiting the Earth planet, basically the planet that's orbiting and spinning will disappear, will hide, and the other version of that planet will, you know, become visible, will be shown, giving the effect that there is only one object and the behavior is changing. That's not exactly what's taking place. The behavior is staying the same. I'm just hiding that particular object with that behavior you don't want to see, and showing the one that you do want to see, which is, you know, how it works currently. If I was a better programmer in Java 3D at least, then maybe I'd be able to change the behaviors and stop using so many resources with 4 models of each planet. In addition to that, because there's 4 models of planet Earth, I also had to make 8 models of the Earth cloud, which is a separate model from the planet, but it is attached to the same branch group. And again, the clouds will either spin or not spin, and they'll either be attached to one of the Earth planets or another. So I needed 8 copies of that. I'm not sure about the Earth atmosphere, whether that was 8 or 4. But again, you know, the amount of models that's actually in the scene is quite intense. Especially if you look at it from a vertices point of view. Each one of these globes or spheres is probably made up of, I don't know how many verts each, but then you've got 4 of them, and then you've got 8 of another one, you know, and so on. There's a lot of information for your computer to process to be able to draw these to the screen all at the same time, all animated or not, depending on your choices, you know. But I would be like, if you can do anything with it. As far as using it, just double click the bat file to start it off. Make sure that bat file is in the folder with the jar file and the res folder. Everything will work fine. It doesn't install anything to your computer. It runs from that folder and stays in that folder. When you double click the bat file, the CMD will open up, and that's like your console. All the print line art that I've added to each of the modules will be shown in there, which should basically tell you, you know, how many modules that's in there. I didn't put the view branch in the console, or maybe I did, but I commented out a later version. But I don't see that coming up at the moment. But every model 3D object that is loaded into the memory will be seen in the console though. Because at the creation of each one of those, I've got a system out print line statement. So every time that's called, then, you know, something gets printed to the console. But yeah, I hope you like it, enjoy. I passed my degree with this piece of software, so I must have done something right. Although I didn't actually pass it with the software, I passed it with a report about the software, and I may include that in the download as well, just so you can get to read, you my ramblings and wafflings. Thanks for checking this out anyway.
Thank you.